Hey everybody. Good, I have a volume. So, my name is Chris Noring. I am a Google developer expert. As you said, I'm here from London, but it's awesome to be here. It's a very beautiful country. My first question to you guys, how many are using Angular 2? How many are using Firebase? Okay, a few hands. Good, good. So that's probably why you're here on a Sunday at 4 p.m., am I right? Awesome. Let's begin. Firebase with Angular 2. So let's talk about its history. I know that Matteo at 10 o'clock today covered what used to be Firebase, but let's talk about it once more. So Firebase started in 2011 with Andrew Lee and James Tamplin. So at first they only had a real-time database, and that database had an API. And of course they were acquired by Google in 2014, and the rest is basically history, because after that a lot of products were added to Firebase, a lot of things you could do besides the database part. Today I will, however, cover mostly the database with Angular 2 to get you started. So it's now a full suite, looking like this. So I think you've seen this picture before today. The arrow there points out the real-time database that I will focus more on, but the gist of it is that we have a database in the cloud, which means that you can consider your Firebase app as having a backend as a service. So the only thing you need to focus on is the JavaScript part. Let's first talk about three-way binding. So to cover three-way binding, let's first talk about what two-way binding is. I suspect that you already know what that is, but let's cover the basics. So in a two-way binding, we got a view and a model. We got the one case where the user changes the view, which leads to the model being changed. And we got the opposite case, where the model is being changed by an HTTP call, which leads to the view being updated. So this is very simple, we understand this. As for the three-way binding, it's more than one application. So suddenly here we got X number of application instances. Each instance has a view and a model. We have a user in one application that changes the view, that changes the model, that leads to a synchronization. This synchronization to a database in the cloud will lead to a synchronization that application one will see, which leads to its model being updated and its view being updated. So effectively, we are used to the whole two-way binding from Angular. And in this case, we got three-way binding happening. Let's talk about lists and the problem of concurrency. So a normal list would look like so. It would have three different items. One of the items is being deleted. And we also see that the effect of deleting such item is that we get two items left, but we see that the index is being reassigned. So the two is no more, but a calculation needs to happen for this list to keep its structure. So in real time, we got suddenly user one that tries to delete item 2 here, and we got the second user trying to delete item 3. And suddenly we have a recalculation of indexes. There's a problem with doing it this way. We have a great chance of this being error prone, that an item will be reassigned the wrong index. So there is a better way to solve this. The solution is that we don't consider a list anymore, but we consider it a dictionary with entries. In this case, we got unique IDs instead, so we never have to think about recalculating the index. So this is really how Firebase deals with lists. They are in reality objects instead. Everything is an object in a Firebase database. So we got something called Angular Fire. How many has heard of Angular Fire? Okay, good. That's why you're here, right? So Angular Fire here is for Angular 1. The one that's for Angular 2 is called Angular Fire 2. You will be given these slides later, but if you want to read more about what this framework can do, it's in this GitHub link. So let's see. We got all the Firebase features here on the blue circles and all the Angular Fire features being implemented in the red circle. As you see, it's not a perfect match for each other yet, which means that Angular Fire supports around 70 to 80% of all the things that are possible in the Firebase API. But we still have a very good experience dealing with Angular Fire. So let's shortly cover what Angular 1 is able to do. So we got Angular itself, and we got a service called $Firebase auth, which deals with authentication. We got the Firebase object that deals with CRUD operations with the object. And lastly, we got the Firebase array, which deals with lists. Looking at Angular 2, we got pretty much the same thing, but it, of course, changes name. So for Angular 2 and Angular 2, we got the Angular authentication class, we got the Firebase object observables that deals with objects, and we got the Firebase list observable that works with lists. If you have any questions while I'm talking, please ask them. Don't be shy. So to deal with Firebase applications, we, of course, have some admin tools that's going to make it easy for us to work with our Firebase application. After all, the database is in the cloud, so we need a good way to configure that. So what can the admin tools do for us? They can set up our project, of course. We can configure authentication and authorization, and we can do a lot more things than that. So the first thing you need to do when you want to create your first Firebase database, so you can actually use it, is you go to firebasegoogle.com and you go to a console link at the very right. Once you do that, you are shown this image. So here, all of your Firebase projects resides, and as you can see, you can either create a new Firebase project or you can import an existing Google project. So in this case, I have an existing Firebase project, which is my database and all the services I have configured with it. So the first thing we probably want to do is to create our Firebase. So the first thing we do is we go into the console, we click the database on the left here, and we are presented with a lot of tabs, but we select the data tab, and once we have the data tab, we have the database instance and a bunch of collections here that I've already pre-created. But the first time you would create your project, this would be completely empty, of course. So what you need to do is basically just use the pluses and the X's to create your collections the way you need them. So how hard is it to get started with Angular 2 and Firebase? How hard is it to actually add it to your application? It's actually very easy. So the first thing we need to do is we need to find a few configuration data about our app. So we go to the very top, we click that, and we say that we want to add Firebase to our web app, and we are presented this configuration window with a lot of configs. I've struck those out because those would be very specific for my app, of course. You just take this config, you copy-paste it, and you assign it to a variable here. So once you hit your Angular 2 application, you have a so-called ng module root. So once you have that, you have the config to the right here, sorry, the left. And the only thing you need to do is to call the Angular module initialize app with the proper config. That's it. That's all you need to be configured with Angular 2 and Firebase. So when you come to this point, you have a working connection. Okay, that's great. So I have a working connection. What do I do then? Well, we need to inject our instance, and if we're used to Angular 2 applications, what we need to do is just inject it in the constructor, like we're kind of used to in Angular 2. Once we have the Angular instance, we can do things with it. So first inject, and then depending on what we want to do, we can call the AF instance, database, or either list or object, depending on if we're going to talk to a list or an object. And of course, lastly, if we want to log in or log out or do something that has to do with authentication, we call the auth property. That's very simple. It's a very simple API. That's not a lot of things that we need to keep track of. Any questions so far? Good. So you're either with me or asleep. One question. You can actually create collections by What you would effectively do is that you would connect to its parent, and on that parent you would create a child, and that child would be your collection. So it is possible to programmatically create a collection. That was your question, right? Yes. Yeah, exactly. You can absolutely do that. But I would say that normally when you start out with a Firebase project, you do a bit of UI, creating collections, but also some programmatic, depending on your situation. But yes, you can use both ways. Thank you. So, of course, we are talking about a database in the cloud, and one of the things we need to care about immediately is security. I mean, at this point, our app is, we have a database in the cloud and it's completely unprotected. We don't want that, right? We don't want anyone to mess around with things. So, our client would be unsafe by definition. It is JavaScript. It is probably readable by anyone. Even if you minify it, you can probably, read the code anyway if you try to deminify it. So what do? We protect our data as best as we can. We can protect it through authentication. We can use authorization. And lastly, we can use validation on our structure to ensure that no bad data enters our collections. So let me show you all of these three things. So for authentication, there are different ways we can authenticate our users. We can use anonymous, which is no authentication at all. We can use custom, OAuth, username, password. There are, I think, 4 or 5 different ways that we can authenticate our user. So you will definitely find a good way for you. This is very simple to do. So what you do is you click the authentication and you are given all of these choices that are available for you: anonymous, GitHub, Twitter, Facebook, Google, and also email password. Social logins, basically. So what we do is we try to enable one of these guys, but for us to be able to enable it, we need to give it a lot of data to make it properly set up. So what we do is, on the right here, we have our Firebase console, and on the left we have GitHub. So I've effectively taken a print screen from the console and a print screen from the GitHub, so you can see. So we start with the Firebase console. We obtain the callback URL, and on the left we enter that in our GitHub, and we just press register application. This will give us a client secret and a client ID that we can paste into the Firebase console, and we're actually ready to go. You see, 3 simple steps, and we have enabled social login for our Firebase application. Very simple. Of course, once we do that, we're not quite done, right? Because we still need to log in or log out the user. So we still need to do that part in code. So as we see here, our auth object can do login, can do logout, can get authentication to get the current status of our login session. And we can also create users programmatically. So we don't have to set up every single user. We can also do that in code. When you log in, you can either specify an email password or you can give it a provider, and the available providers would be Twitter, Facebook, GitHub, and Google. So you see, it's very, very simple to log in your user. You just need to do the setup that I talked about and specify a provider, and your user is logged in, and they're ready to see your data. Of course, this is only authentication. Authorization, I would say, is even more important. Of course, you let the user in, but it's also very important to protect a user. I mean, imagine that you're an administrator. You don't want people to see admin data, right? So, first off, we have the database tab again, and we go into the rules tab. And the rules tab, on a high application level, can actually say what are the rules for read and write. In this case, when I say that authentication equals null, it's the same thing as saying there's no authentication happening at all. We will just let the user go straight into our app and show him all the data possible. Once I say authentication is not equal to null, I'm effectively saying I'm going to use an authentication method. So remember, in debug, you would use authentication equals null, but in production, you would set the lower one. And of course, if I do a read like this, I would have read access, and I would have a write access by using the .read or the .write. Sorry. I was pressing. Yeah, I was correct. Okay, so of course that was on a high level. That was for the entire application. We want to be more specific than that. Probably we want to set different kind of authorization rules per collection. So in this case, we have a collection called foo. It has read and write properties. In this case, we say that foo, we can read all the data from foo, but we cannot write to it. Very harsh rule, but that's the way. But of course, we need to understand the rule evaluation completely, because what we did right now was a very simple case, but we need to understand how the rules apply. So in this case, we got the foo collection, and under the foo collection, we got the bar. And the bar has specified that read is true and write is false, and it also has a child property. You would think by just looking at this that, well, this should be fine, right? Well, it's not so fine. I will show you why. So we actually get an access denied if we try to read foo. Is that surprising? A bit. So the reason for that is that we have not specified any rule here for foo. We do have specified a rule for bar. We have told it that read is okay, but foo has no rule whatsoever, which means we have default deny. So foo bar would be allowed to do read, and foo child here would, foo bar child, of course, would be have access granted. Which means that as soon as we have a rule, it is inherited from its parent, but if the parent doesn't have a rule in the first place, we have nothing to inherit, right? Which means that our rules are cascaded. They are inherited from our parent, but they are atomic. So we need to remember, if we don't set a rule, it's the same thing as default deny. So with authorization, let's try to sum that up. We can set read and write rules on the whole database, per collection, and rules are applied atomically, as I said, and they are cascading. They are inherited from the parent. And if you want to read more what's possible, here's a link. As I said before, you will be given the slides. So validation. This is also a very interesting and very powerful thing that can protect your collections. So you can validate your structure. We can actually stop erroneous data from entering our database by beforehand say, this is what a valid structure will look like. So in this case, we can set validation rules. So we have a rules collection. We have the rules and we have an order collection. And under that order, we have specified clearly that name and quantity, they must be there. If we try to do any kind of insert or update, name and quantity must always be there. So in this case, we try to replace the whole data set and say, well, I will only give you name, right? This will actually not work because it must have quantity. So we can actually define what an approved structure looks like. But there is more. We can validate input data. So in this case, we can not only say that name and quantity needs to be there, we can say that quantity needs to be a specific number. In this case, we say you need to be a number, you need to be larger or equal to 0, or you need to be equal or less than 99. Which means this set will fail. It's trying to insert 101, right? 101. Because it needs to be 0 to 99. So it's very powerful. We can actually say that incoming data needs to, validate structure-wise, but also value-wise. Of course, working with data. Let's first look at how we can establish a connection to the object in the first place. So we can do that with either a relative path or an absolute path. If we have set up our config correctly, we seldom need to use the absolute path, but we'd rather be talking to a relative path. But there are, both these options available for you. As for retrieving data, it's important to note that when we're dealing with Angular 2, dealing with async data straight away without using the async pipe will actually break because the data won't be there, right? Because the first thing you do in an application is to perform a get. And if your object is not there, the template will actually crash. This is a big difference from Angular 2 to Angular 1. In Angular 1, it was like silent fail. It didn't show us the error. In Angular 2, it's like, you haven't set this data. I don't know what this is. You say that you have a item property with a name property on it. I don't know what item is. Item is null. This is a big difference in Angular 2. So this is the reason why we're using this syntax that says, if item has been set properly, and it has arrived, and it has a name property, then all is fine. So the question mark here is the conditional that says, have I been fetched? And also the async pipe says that we're dealing with observables rather than dealing with the actual data. That's an important thing to say. So this is a very simple piece of code, but I really want to reinforce that when we deal with Firebase, we need this kind of construct to make sure that we display the data in a safe way without it crashing in the template. As for changing data, there are two different ways that we can change data. One is using the set method. And if we use the set method, this is called a destructive behavior. Because what we try to do is effectively replace the ABC123 with a prop val. So this is destructive. This destroys the data. The other more safe approach is the non-destructive way with the update method. The update will just amend the data to the existing data. So remember, destructive, non-destructive. Learn the difference or your database will look very funny. So for lists, of course, we got the relative path, we got the absolute path. But lists, of course, they can be millions of lines of rows. So for that reason, it is giving you an optional query. And that query can be specified to limit the number of rows, but also you can specify different kind of queries saying where age equals 18 or bigger than 100 and so on. So don't try to fetch all the items at once, but try to pose a good query so your result set that comes back is very limited in size. But remember, the query is optional, but I really recommend to specify something. So as for changing data, we got the push method, we got the update with a key, we got items remove also with a key. I will explain what the key is. And we got the items remove, which will effectively delete the entire list because it will take away every single item. So what is this key? When you fetch the whole list and you repeat every single item out on your view, you got the $key. So the $key is actually the unique ID that exists inside of the Firebase database. So as long as you refer to that one when you attempt a update or a delete, it will know which item to remove or update. So remember that. So here we got an update item method, we got the item and the $key, so we send that in, for example, and we perform an update and it knows which item to target. This is probably the most important aspect. I mean, Firebase databases or Firebase projects as a whole are really made for collaboration applications. Imagine that you build something like a movie booking or you try to book washing times. You don't want the neighbor to take your time and then you try to take the same one and you have no knowledge of that. So you end up both showing up to the, try to wash your clothes and you start a fight. You don't want that, right? So you want some way for the CSS to tell you that this time slot was taken, I better take another time slot. Regardless if it's trying to wash your clothes or trying to book a movie ticket, we need to know when a change happens in the database. So how do we do that? Angular Fire is very simple in this manner. It's dealing with observables when we're talking to, for example, /items. And if we try to perform a CRUD, it's going to give us a promise back. I will show you what I mean. So in this case, we have established a connection to the item. So imagine that this item was instead available times for to wash your clothes. So these are all the available times, and suddenly your neighbor is going to book a time. In your subscribe method is when it's actually going to tell you, well, 12 o'clock was taken, so the only available times are 4 o'clock and so on. In the subscribe is where you see that the data is being changed somehow. But of course, if we've got other kind of issues, for example, we try to perform a delete or create or something, and we don't have the proper authorization to do that, then we have a CRUD method. So here we're trying to do a set, and something is erroneous and comes back to us and say, this is not allowed for some reason. So you use that promise to indicate whether your operation succeeded or not. So remember, observables versus promises, they're used for different things. Data design. This is a tricky one because we are dealing with a JSON database. We are dealing with a tree-like structure. So normally we would be dealing with a SQL database. We would be normalizing the database, right? We would have the data being constructed in a certain way that was nice. This is a bit different, because if your data starts looking like this, you can imagine the number of levels. Firebase allows you to do 32 levels, but for God's sake, don't do it. So why? Why shouldn't I do that? Why shouldn't I have a very deep tree? Well, imagine yourself, you try to get foo here, right? You've got 32 levels of data. Imagine how massive that data can actually be when you do a get. That's not all. Imagine that you have to keep track of access on 32 different levels. I mean, you have to say that, well, this item is okay for you to fetch, but not for you. So try to make it very shallow. Have shallow trees. So what does a shallow tree mean? It means basically try to only, when possible, in this case, store metadata. Don't store the entire order in here. Try to store an order with only a title and a timestamp and make sure that there's a different collection for the rest of the order. So in this case, we got order items that points to the order ID, and you see that in the order items, we kind of try to group every single order item under an order ID. This is a way for us to allow for shallow trees rather than deep trees. So it's a different way to think about how your database should look. So this is actually my last slide, so I thought I'd just summarize everything that I've said so far. So Firebase is a backend as a service. It's Angular is a wrapper around the Firebase API. Angular is for Angular 1. Angular 2 is the one used for Angular 2. It's a very simple API, as you saw. We used list, we used object, we used auth. 3 things to keep track of. Also, that references to a point in the database are observables. The actions that we perform, the CRUD actions such as create, delete, and so on, are promises. And your data can be protected by authentication, authorization, and validation. And it is a platform. It's not just a database. But I guess you heard that from Matteo already. It's very big, right? Firebase is not that thing that started in 2011 anymore. It's a very, very big project. Thank you so much for listening.
Actually, I've got a couple, but
Yep.
I'll let the others.
As they say.
First of all, observables. If the data is changed in the database, then the data will be changed in the UI almost immediately. Is that true?
It will. On the other hand, because you have an observable, you're able to, for example, show a CSS, because of it. That's saying that an item disappeared, then you can just show a pop-up or something, that this happened.
So this works with WebSockets or something?
Sorry?
This works with WebSockets?
Sockets?
Sockets?
Yeah, so I mean, the underlying thing is kind of a real-time protocol, right? So it's able to push.
But I don't have to deal with that as a developer.
No. You don't have to deal with anything. The only thing you deal with is observables and Angular 2.
Hi, thanks for the talk. Can you go back to slide where you talk about not shallow trees, structures, design, exactly there, or
Here?
yeah.
Yep.
So in this case, how you relate actually that order ID 1 is the same as in both structures in metadata? Do they have some ID and then you can reference them to understand that they are the same?
Yes, thank you for the question, first of all. Yes, so the order ID is probably what it would be called for real. It would be an ID that Firebase would generate for us. So I'm just trying to make it visually visible for you guys. But yes, order ID 1 would, correlate here, as you see the colors. So that's how.
I have a question. How is it possible to create user entity and create unique ID with the order, then make sure that have kind of relation between the user ID and order, and to prevent removing user while he has orders. So typical SQL question.
Okay, so you're saying basically that if we had a normal relational database, we would have a problem, right? We try to delete a user, and that user would be referenced in a lot of collections. The simple answer is that or the scary answer is that in a JSON database, you wouldn't have a error happening because it would just say this is allowed. So you're very responsible for making sure that your data is still, atomic. So normally when it comes to databases, you try to not use delete at all, right? Because we tend to use delete flags and say, we set a boolean, is this, deleted? True, probably. So, I mean, normally when you deal with databases, you don't ever delete because of these things, because foreign keys. And I really think that should be a tactic that we use in these. People tend to solve that in a different way. Sometimes they only store the user ID. Sometimes they store the user ID plus the name, or sometimes they store the entire user object. But I'm trying to say that try to be as shallow as possible. So if preferably it's only the user ID, but if you really need to have the user ID plus the name, but nothing more. So try to make it as thin as possible, so you can refer to the actual heavy user objects in another collection.
Is there any support for offline functionality on the web?
Oh, so you're saying more like a progressive web apps, that we would have it like a tactic for caching to the local storage, and once we get a connection, it would try to do the actual read, or? Very good question. I don't know the answer. I will have to find out and tell you. Try to follow my Twitter tag. I will try to Twitter as many answers as possible that I can't answer right now. So, thank you.